Alright, this question we have not done. A spherical ball, surface area. We have not done this one, right?
No, sir, not done in the class.
I have given as your homework, right? Okay. Let us understand the question. It says a spherical ball of surface area 20 centimeters square kept at the center of a hollow spherical shell B of area 80 centimeters square. So this is a hollow spherical shell B A. This is a spherical sphere A, and it is kept inside another hollow spherical shell A like this. So this is surface area A. Okay, this is A, and this is B.
Sir,
Yes.
see, is the answer 0.91, 3.67 and 2.75?
Yes. Yes. The surface of A and the inner surface of B emit as black bodies. So both of them are black bodies, and their temperature is 300 Kelvin given in your question. How much is the radiation emitted per second by the ball A? So what it is asking for the emissive power of A. What is the radiation emitted per second by the ball A? That means the power. Do you remember the formula for emissive power? What can I say? The emissive power?
Sigma T to the power 4.
Sigma, I'm not talking about intensity. Power is multiplied with area, right? Sigma area of A into T power 4. It is the emissive power of A. So that should be your first question, answer of this question. That emissive power of A is equal to sigma area of A into T power 4. That is 5.67 into area of surface area of this ball is 20 centimeters square, means 10 power minus 4, into temperature to the power 4, means 3 power 4 into 10 power 8 into this is one 10 power minus 8 is there. So I think 10 power 8 will get cancelled out, and 10 power minus 3, 2 into 5.67 into 81, yes, into 10 power minus 3, it will come near about 0.92. I'm sure you have got the solution. How much is the radiation per second by the inner surface of B? It is only talking about the inner surface. Look, outer surface of B will also emit radiation, but it is not talking about the outer surface, only the inner surface. So the inner surface of the B, that will also radiate energy, right? And how much will the radiation energy of that radiation power of this emission of inner surface of B? What should I write it here? How much is this one?
So sigma into 8 of B into T4, T to the power 4.
Yes, definitely. Sigma of AB into T power 4. Right. But you can understand that out of this entire radiation, few amount will be falling on this A, and few amount will fall to its surface, own surface.
Yes.
Right. So let us first find what is the total radiation of emissive power of inner surface of B, that is sigma AB into Ts power T power 4, right? If the question did not mention the inner surface, then you have to multiply it with 2, right? Look how accurate the question is. It is mentioning that what is the by the inner surface of B, right? So you have to only talk about the inner surface. So sigma is 5.67 into 10 power minus 8 into area of the surface B, inner surface, it's 80 into 10 power minus 4 multiplied by 81 into 10 power 8. Same thing as this one, but this was multiplied with 2 and it is 4. So 4 times of this will be your answer. 3.68 watt approximately will be the answer to this question B. Now the third question says how much energy falls back on the surface itself. So how much is this one?
We take a factor F, which is falling on the body.
Yes, yes. That factor is known as form factor, right? That factor is known as form factor. Form factor. Someone was asking me in WhatsApp what is the name of this factor. This factor is known as form factor. We can solve this question by form factor definitely if you know. But if I do not have any idea about form factor, as I told you that it's not in the scope of your syllabus, so I can also find it by this one. Look, for the body A in steady state, whatever energy is incident on it, that is radiating out. Yes or no? Because it is in steady
Yes,
state.
black body. Yes, sir.
Yes. So what is the P incident? If I say this is incident on body A, so what is the power incident on the body A? Can I say it is the same as 0.92 watt? Yes or no? Because in steady state, these two power should be the same. Am I correct in writing this equation?
Yes, sir.
Yes. So if this is the incident and it is the total emission by the B, so what is the extra amount that is falling back, power back?
8 minus 0.92.
Yes. So power back is equal to only the difference between 3.68 minus 0.92 watt, right? So that is 3 times of this one, so 2.76 watt. Right? Alternately, if you want to do it by form factor, then I know that what is form factor of B into area of B, that is equal to form factor of A into area of A.
Area of A.
Now what is form factor of
F
A?
of A is 1.
Is 1, right?
1.
So form factor of B, that is equal to area of A by area of B, and that is 20 by 41, 81 by 4. So 1 by 4th power is incident on it. So what is the power back?
3/4.
Back power is 3/4 of that. 3/4 of EB. If you do 3/4 of EB, you will find the same thing. Right. So if you know the form factor, it will give you an edge. Otherwise, the questions will be set in such a way that you can understand, you can find the answer even if you do not have any knowledge of form factor. I think it's clear to all of us. Alright, I've taken this from HC Verma. You will find this question in HC Verma. Now come to this question. A metal sphere A of radius R is kept inside another concentric hollow shell B. B is a black body and emissivity of A is 1 by 4. At thermal equilibrium, temperature of both the bodies is T Kelvin. If half of the energy radiated by the inner surface of B falls on the surface of A, then find the radius of shell B. Also find the external power supplied to shell B to maintain its temperature constant at T Kelvin. It is a very similar question that we have just done. The difference is only that now the body A is not a black body, rather it's a other body which has an emissivity given, right? So let us draw the same diagram. This is the body A, and let me draw it some big sphere like this. So this is A given at a temperature T, right? A at a temperature T, and this is B at the same temperature T, right? So I am supplying some external power to the shell B, but there is no external power to the shell A, right? So let me draw first what are the exchange of heat powers between the bodies. So this is the body B, which whose inner surface I am talking about. His inner surface is radiating some energy, which is, it is a black body, so it is sigma into its surface area, suppose B, into T power 4. Out of this much radiation, it is saying that half of the energy is incident on the surface A. So the surface A incident energy is half of this, half of sigma B T power 4. Definitely the rest half will fall back on it own surface, half of sigma B T power 4, right? Now come to the body A. As it is not a black body, so the incident energy that is falling on it, few part will get reflected, right? And what part will get reflected? Can you tell me what amount of this incident energy will get reflected back? Yes?
So three-fourth.
Yes. 3/4. 1 minus E part.
Yes, sir.
So 3/4 of sigma B T power 4 by 2, that is reflected back. And this will completely fall on the inner shell of B. Along with this, it has own temperature T, so it will also emit, and the emissive power will be E sigma A into T power 4.
Yes, sir.
And that will also completely fall on surface B. These things are going inside, and outside only one thing is happening. This outer surface is emitting sigma B T power 4. Have I missed anything, or I think I have drawn every possible situations. Right. So if I talk about for the shell A, for A,
Sir,
yes,
sir, do we need to consider that sigma B T to the power 4 that is going outward?
yes. If I am talking about the temperature of B, then this has to be considered, right? Because it's only not a one surface that is radiating heat. If it is mentioned in your question that it is well insulated outside, right, then you can neglect it. Otherwise, you have to consider it. Right, one second. हाँ बोलो. हम्म. हाँ. हम्म. हाँ. আচ্ছা আচ্ছা করে দিন, ঠিক আছে. হুম. Okay. So what can I write for the shell A? for the shell A, I can write that its absorbed power. What is the power absorbed?
half sigma b t to the power 4.
Not half sigma. Half sigma b t to the power 4 is power incident. What is the power absorbed?
That minus reflected.
Yes, E
Reflected
times
power minus this power.
1 by 4th of half sigma b t power 4, right? 1 by 4th of that. This is the power absorbed. And what is the power emit? Emissive power is 1 by 4 into sigma a t to the power 4. They should be the same, yes or no? If it is at steady state, in steady state, they should be the same. So if they are same, P absorbed is equal to P emit. P absorbed is equal to P emit. Then what we can write? 1 by 4 T power 4 sigma, that will get cancelled out. So can I say B by 2 is equal to A? So the radius of B is equal to root 2 times radius of A. Look, I could also solve the same thing by using form factor. Can you see that? What is the form factor for B to A? Half, right? So if you use form factor, you can directly using form factor. Using form factor, I can also write that surface area of B into half is equal to surface area of A into 1, right? So there also you can directly find the radius of B is equal to root 2 of R radius of A, right? Now what is for B? For B, what is the power that it is taking? What is the power that is falling on it? It completely it takes because it is a black body, right? Whatever power you supplying, it's completely this body is taking that power, right? So if I say that this is the power, it is falling on it. So it is E sigma A t power 4 that is falling on it plus half of sigma B t power 4 and plus 3 by 4th of half sigma B t power 4. All these powers are falling on it in addition to the power supplied P. Can I say this all 1, 2, 3, 4? These 4 are the powers that are incident on it. And it is radiating only to 2 power, this one and this one. Right? So that is equal to 2 sigma Bt power 4. Right? So if you just consider A equal to B by 2, A equal to B by 2, then you will find here it is B by 2, here it is B by 2, so it is B, and here it is B 3B by 8, right? So P plus sigma Bt power 4 into sigma Bt power 4 into A is equal to B by 2, so half plus 3 by 8 is equal to 2 sigma Bt power 4, yes or no? Have I got it correct? So it is 1 or I have done something wrong.
Half plus 1 by 8.
Half plus
1 by 4.
E is 1 by 4, right? Yes, I have not taken this. Half into sigma B t power 4 and this is E is which is equal to 1 by 4. So how much it is? 2 by 4 plus 1 by 4, 3 by 4 plus 3 by 8 means 9 by 8, right?
That should be 1 by 8.
Which one should be 1 by 8?
E is B by 2.
E is
So the first term E into A into sigma T
Acha,
divided by 4.
E is equal to 1 by 4 and A is
And
equal to
A
B by
equals to B
2.
by 2.
Yes, 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 sir. That should be 1 by 8. So now 1 by 8 plus 3 by 8 is equal to 1 by 2. 1 by 2 plus 1 by 2 is equal to 1. So 1, if I take in this side, so you will find that power is only sigma b t power 4. And you can understand this power is only because of this external emission, right? Because internally both of them are having the same temperature, right? So there should not be, ideally speaking, there should not be any heat transfer in between them, right? If you talk about conduction method, if that process were a conduction process, then would I consider any heat transfer between A and B inside?
No, sir.
Definitely not, right? So in that way, you can say all. Why the heat transfers I have taken everything, because this is a radiation, and from previous theory it says that it does not matter even if the body is in steady state or equilibrium, whatever it may be, it will continuously radiate. So that is why I have written all those radiations. But from understanding of the heat transfer, you can easily say that if the bodies are at same temperature, there should not be any heat transfer between them. So whatever is the heat transferred from this body to the surrounding, that is only provided by the power. And if it is well insulated, you do not need any power. The body will have the same temperature as this is in thermal equilibrium. Have you got it? All right.
No, that means without writing all those terms, we could have directly said that it will be sigma b t to the power 4.
Yes, directly. Yes, that I have only said that, as you can say that, as there is no net heat transfer from inner surface of B and A. So power is only needed for external surface radiation. Now is this clear?
Yes, sir.
Have we done this question on Newton's law of cooling? Not done yet, right?
No, sir.
It takes 30 seconds to cool from 80 degree to 70 degree in 70 seconds. So from laws of cooling, from Newton's law of cooling, do you remember what was that law of cooling? What was that law of cooling? dt by dt
Minus kt.
is proportional to, yes, dt by dt is equal to some constant into the temperature difference, right? Here the body temperature is more than the surrounding temperature, so I can write T minus Ts, right? If I take this minus sign here, otherwise Ts minus T you can take, right? dt will be negative because the dt by dt is negative because the temperature decreases, right? I have only found the magnitude of this, that is why I have taken the negative sign here. So dt by dt, according to the average method, the temperature difference is 80 minus 70, right? 10 degree. And the time needed is 30 second, which is equal to K into the body temperature is 80 plus 70 divided by 2 minus the surrounding temperature. Number one equation. And number two equation, again the temperature changes by 10 degree, but this time the time needed is 70 second. Same constant I will write, and it is now 60 plus 50 divided by 2 minus Ts. So from these two equations, I can directly find what is Ts. If I divide these two equations, 1 by 2, if I write, so it is 7 by 3, 1 by 2 is 7 by 3, is 75 minus Ts divided by 55 minus Ts, right? So if you solve the value of Ts, 7 into 55 minus 7 Ts is equal to 3 into 75 minus 3 Ts, right? So it is 4 Ts. 4 Ts is equal to 7 into 55 minus 3 into 75 minus 3 into 75. How much it is?
160.
160, right? Yes. So the temperature of surrounding should be 40 degrees Celsius, right? Remember that in actual equation all these should be in Kelvin, right? I have ignored the Kelvin. I have only taken the Celsius. Can you tell me why I have done that?
The scale is same of Kelvin
Yes,
Celsius.
not the scale. The difference of the temperatures are same in Kelvin and scale, degree Celsius, right? If inside the bracket there would be only one term, I have to take the Kelvin, but it is temperature minus temperature. So 273, if you add here, you have to also add here, so their subtraction will get cancelled out, right? So that is why the temperature difference in Kelvin and Celsius, you can assume the same. You can take the same. I'm sure you have understood this question clearly.
Sir,
Yes.
sir, will there be any situation where we have to integrate and find the time?
Yes, you may have to integrate that one, but it depends all on your options, right? If you find the options are simple numbers like this, go for the average, right? And if nothing is mentioned, also go for the average. As I have told you that the temperature difference is not that much. If the temperature difference here, you can see the temperature difference from 40 degree to 70, 60, 50, they are close to 30, 40 degrees Celsius, right? So if it's in between 30, 40 degrees Celsius, this will give you a good approximation. If the temperature difference is more than that, suppose 80 or 100 degrees Celsius or 100 Kelvin, in that case it's better to avoid this method and do the integration, right? And in your option also you will find that some exponential term is there, e to the power something is there. Definitely you should understand, we'll go for integration.
Okay, sir.
This question, have I given it as your homework? In your homework, have I given it?
Yes, sir.
Yes, okay. So when a calorimeter of 40 gram water and 50 degrees Celsius, then the temperature falls 45 degrees Celsius in 10 minutes. The same calorimeter when 100 gram of water at 50 degrees Celsius, it takes 20 minutes to come at 45 degrees Celsius. What is the water equivalent of the calorimeter? So here I do not use the same constant. Why I cannot use the same constant in the average value? The reason is, if you remember the constant, or if you do not remember, don't worry, you can just write this equation. dq by dt, net dq by dt is equal to E sigma A into T power 4 minus Ts power 4. That was the equation, which is equal to ms into dt by dt. This equation you should remember, right? So from there we could find that dt by dt is equal to E sigma A by ms, and this approximation was t power 4 means t square minus ts square plus t square and ts plus t ts t, you can say t minus ts here, right? So t minus ts and t plus ts. So actually this dt by dt, if you write that, it is E sigma A into 2ts square into ts, means 2 into 2 4 ts cube divided by ms into t minus ts. Look, I have written this equation by assuming that I do not remember this constant value k, because it is not really important in most of the question. But for this question, it is important because you can see that masses are being changed. Initially 40 gram, now it is 100 gram, right? So what I can do, I can take this numerator part still is a constant, right? This is not changing. So dt by dt, for the first case, if I write dt by dt is 50 minus 45, right? 50 minus 45 divided by 10. Even if it is in minute, no problem, I have to just divide it. So that is equal to some constant, now I can write, divided by m into s. Now look, calorimeter is also there, right? So this m into s is not only for water, right? So I can write it is mass of water, which is 40 gram given in your question, plus water equivalent of the calorimeter, right? Into, if I take now both water, then specific it will be only 1 calorie per gram degree Celsius. Can I write this equation? Just check if where mw is water equivalent of calorimeter. Water equivalent of calorimeter. Right. So this is our first equation. And in the second equation, 50 minus 45 by 10, it's not 10. Now the second equation, it's 20. That is the same constant divided by 100 plus mass of water, means water equivalent of the calorimeter, into specific heat multiplied by T minus Ts, right? T minus Ts. Look, both the temperatures are same. Temperature in both the case is 50 plus 45 by 2, right? So that is why I have taken T, which is equal to how much? 47.5, right? Then I can just divide 1 by 2. Then I will say 2 is equal to this divided by this. 2 equal to 100 plus mw divided by 40 plus mw, right? So 80 plus 2 mw is equal to 100 plus mw. So mw is equal to 20 gram. That should be your answer. That water equivalent of the calorimeter is 20 gram. Wind's displacement law. We have not done it, right? So Wind's displacement law talks about black body radiation. It's only true for black body radiation, remember, not for any other body. You can find this graph. This graph means this particular property. The graphs are similar, but for a black body, Wind's displacement law, Wind's notice that if I increase the temperature, the area under the graph will obviously increase, right? And you know that this area under the graph is the total emissive intensity, where this y-axis represents the spectral emissive intensity, right? And x-axis is lambda. So the temperature increases, area increases, no problem. But what he noticed that the lambda, for which lambda, when E is maximum at a particular temperature, E lambda means spectral emissive intensity is maximum for a particular wavelength, right? And you will find that as I go on increasing the temperature, that wavelength corresponding to the maximum spectral intensity decreases. From this graph, it is well understood. You can see I have increased temperature from T1 to T2, but this lambda decreases from M1 to M2. Similarly, lambda M3 is less than lambda M2, right? So he then noticed with experimental value that lambda into T is a constant. Lambda into T is a constant. It's known as Wind's constant, 2.89 into 10 power minus 3. Not very important constant to remember. Even if you do not know or do not remember this constant, you will be able to solve the questions, right? Most of the questions will ask you about a ratio. And so we can use this equation, Wien's displacement law, in few different cases, right? But it is for a black body, and you can understand it, right? I don't think there is any other thing to discuss in this equation. It's an experimental fact and we have to remember it, otherwise there is no way to solve those questions. This question
Sir?
says, yes, tell me.
Yeah, if it's for a black body, why can't it be extended for other bodies also?
Because for
Is it
other bodies the graphs are similar, not exactly, right? So exactly this constant equal to b, that may not be the same constant for every other bodies, right? So
okay,
this
sir.
experiment was actually done for black bodies, so we will only talk about black bodies in Wien's displacement law, right? Now let us talk about this question where spectral emissive intensity is plotted against wavelength in two different temperatures T1 and T2, and the graphs are plotted and area are found to be A and 9A, or rather 9A and A, because the area under T1 is more than area under T2, right? So you think about 9A and A, 9A and A, right? So what is the ratio lambda 1 by lambda 2? You have to calculate. How we can find 1 by root 3? We know that area is
Area is
sigma into T power 4, right? Area is sigma into T power 4. Intensity is proportional to fourth power of the absolute temperature. So I can say that 9A by A is equal to T1 power 4 by T power 4, T2 power 4, right? So what is T1 by T2 is equal to root 3. But lambda 1 by lambda 2 is T2 by T1, right? So that is 1 by root 3 is the answer of this question. Have you got it? Yes. Now, one question from solar radiation. Solar radiation is the radiation that is coming from sun, and on earth we are finding that radiation. But remember that the distance between earth and sun is much larger than the radius or diameter of the earth, right? So this question says that earth receives a solar radiation at a rate of 8.2 joule per centimeter square per minute. Assuming that the sun radiates like a black body, calculate the surface temperature of the sun. The angle subtended by the sun or on earth is 0.53 degree and Stephen's constant is given. Alright. Try to understand this question. Let us assume the temperature of the sun is Ts. Right? So what is the total radiation power or emissive power by the sun?
sigma at T to the power 4.
Sigma into area of the sun, sigma into area of the sun into Ts power 4, right? Now, if I want to find the intensity for this radiation at certain distance r, here the distance is r. Suppose I want to find the radiation intensity at certain distance r here. So what should I do?
Divide by the area of that small point.
Area of that small point. No. Look, if you imagine a spherical shell of radius r, can you say that every point on the spherical surface will receive the same intensity because it is the same distance away from the sun?
Yes, sir.
Yes, sir.
Right? So what is the intensity I? Can I say that I into 4 pi capital R square is that power? Because this power is received totally by this surface. Can you understand that? This power cannot cross that surface without this sphere. Suppose you have a source here, and if you surround this source with a sphere, can you say that this entire power will first fall on this surface?
Yes.
Right? So what is the power per unit area? That will be the intensity at every point on that surface.
Sigma is ts per 4.
Yes. So power per unit area, that intensity can be written as sigma as ts power 4 divided by 4 pi capital R square. Can you understand what I have written here? This power is uniformly distributed over how many surface here? What is the surface? How much surface area? 4 pi r square. 4 pi r square, yes. So each unit surface area is taking this much power, which is nothing but the intensity. So that intensity is falling on Earth. Yes or no?
Yes.
So I have to just equate that and I can find my answer. Now how do I find what is surface area of Sun? Surface area of Sun is equal to pi d square by 4, where d is the diameter of the Sun. Yes or no? And if I know this angle theta in radian, can I say that d is equal to r theta? Because theta is so small? Yes or no? So I can write that this is equal to r theta. Now what is theta? Theta is equal to pi in radian. I have to convert pi by 180 into 0.5. Right. So now I can equate this intensity in joule per meter square per second. So it's 8.2. Let us first write this one. 5.67 10 power minus 8 into pi by 4 d square. D square is r square pi square divided by 18 square into 100 into 53 into 53, 53 square divided by 10 power 4, right, into ts power 4 divided by 4 pi r square, right, and that should be equal to 8.2 joule per centimeter square. So 10 power 4 joule per meter square per minute means divided by 60 per second. Have I got this equation correct? Only unknown is Ts, I can find it, but the calculation is lengthy. Right? What I can do, approximately 18 into 3 is equal to 53. Can I write it? 18 into 4 is 54. So approximately I can make it 3. Right? Look, r square gets cancelled out. 1 pi you can also cancel. right? So now I have to calculate Ts power 4, which is equal to, now 10 power 4 is here in this side, so that is 10 power 8.2 divided by 6 into 10 power 3 multiplied by 4 into 10 power 6 divided by this entire term. Achha, 4, there is one 4 that will also come here, right, and divided by 5.67 into 10 power 8 into 9 pi square into 9 pi square, right? So look, that is the equation. But again, if you want to solve it, pi square I think can be assumed to be 10, right? Approximately, I'm talking about approximately. You can cancel pi square with 10, so it is 10 power 5, right? And 6 into 5.67, 5.67 means 6 into 5.67, 30, 32, like this, right?
34.
34. So I can cancel 8.42 into 4 with 6 into 5.67, right? So now we are left with 10 power 16 into 4 by 9. So I think Ts is approximately 4 by 9 to the power 1 by 4 is root 2 by root 3 into T power 16 means 10 power 4, right? That much Kelvin can be the temperature of the sun, right? Approximately, if you calculate this one, near about 8,000. What is that Kelvin? Root 2 by root 3 is how much? Root 2 by root 3. You can calculate.
So it will be 81 something.
Yes.
Near about 7,500 volts.
So near about 8,150 Kelvin. Right? I can also calculate the temperature of Earth from this data. Can you tell me what is the temperature of Earth then? Look, if you consider the Earth also to be a black body, consider Earth also to be a black body, then the intensity that is falling on Earth are parallel because Sun is at a very large distance away. Yes or no?
Yes, sir.
So how much intensity Earth will, what is the power the Earth will receive?
8.2 pi r square.
I into pi r square, if the radius of Earth is smaller, I have assumed. And that can be equated to, if the temperature of Earth is Te, is it equal to 4 pi r square into sigma into Te power 4?
Yes, sir.
Right? So actually temperature of Earth, yes.
So we are assuming that Earth is also a black body.
Earth is also black body, I have assumed, yes. Earth is also black body, I have assumed it. Right? So that I can assume that most of the energy that is falling on it is incident. Incident on it is absorbed, but there definitely few part is reflected back, that we all know. But here we can approximately find if it is a black body. So Te is equal to T power 4 is equal to I divided by 4 sigma, right? I divided by 4 sigma. So I we know that 8.2 into 8.2 by 6, 8.2 by 6 into 10 power 3 and divided by 4 into sigma is 5.67 into 10 power 8, right? So approximately this much Kelvin if you find T power 4, 8 plus 3 it's 11, 11, so I can take it 82, right? 8.2 by 10, so 11, 12 if I say, so 0.82 divided by 0.82 divided by 6 into 4 into 5.67 into 5.67 into 10 power 12 then, right? So then I can calculate 0.67 if I cancel it. So approximately how much it is if I say TE fourth root of this one, right, into 10 power 3, fourth root of this one. I don't know what will be the value because 82 divided by 24 and divided by 567, that is equal to 0.006, means 6 by 1000, right? 6 by 1000. 4 into 10 power 3, right? So approximately you can calculate what is that value, root
So,
over
but
of,
it is differing a lot from the practical value.
yes,
Right, it's differing a lot from the practical value.
is it, what is the
Because,
value you are getting?
sir, like 5 degrees Celsius it is coming.
Only 5 degrees Celsius it is coming. What is root over of 0.006? One second. Is it coming only 5 degrees Celsius? Square root of 0.006, 0.0774, 0.278. No, it's coming 278 Kelvin. Yes, 278 means 5 degrees Celsius. Yes, it's coming 278 Kelvin. So actually, I think this data is not correct, right? It's 278 Kelvin. It should come near about 300 Kelvin. This data 8.2 joule per centimeter square per minute. This data is not correct, I think. That is why it
Sir,
is coming like this. Yes.
sir, Google the temperature of sun surface. It is
Yes.
somewhere near about 5778 Kelvin.
Yes, it's near about 6000 Kelvin. It's near about 6000 Kelvin. So I think this data is not correct. But whatever, if the data is correct, you will find the correct answer. The process remains the same. Okay. Okay.